Okay, so Skynotes for March. The really big news, and this picture comes up later, so thanks to Honor Wheeler for taking this fantastic picture, but it does come up later and I'll mention it later. But the really big news is that this thing actually had some activity on it a couple of weeks ago. So this is actually what it looks like at the moment, or at least it's what it looked like yesterday night. This is of course the sun. The star at the centre of our solar system, which basically seems to have pretty much turned off. John Cook sent me this really interesting graph, and what's interesting about this, so what this shows, the grey lines show white light solar activity, so sunspot number. The red lines show prominence activity. And what's happened this time, so we're over here somewhere, is not only is the white light activity pretty much stopped, but so is the prominence activity as well. So if you've recently spent a lot of money buying an H-alpha telescope, or got one for Christmas, you might want to trade it in for something else. Obviously, you know, graphs like this are no prediction of the future, but the sun certainly is going through an extremely quiet period. But this is the big news. There were a couple of active areas, two very small active areas, and this is basically what solar observers are getting really excited about at the moment. Actual sunspots. Real, honest-to-goodness sunspots. So this one, AR 2736, was the probably the most complex sunspot that's been on the sun, seen on the sun for quite a long time. Really nice picture in white light here, taken by Carl Bauer. Here it is in H alpha, so there it is. A real honest-to-goodness but rather small sunspot. And then this is a flare in that system. This was taken by Mike Nichols, I think. I'm not entirely sure because he hasn't got his name on here, but I think this is Mike Nichols. So there is activity on the sun, very, very low level. It's, you know, we're obviously hoping that after this minimum the sun will actually pick up and actually start doing something again. But I would certainly sell any shares that you might have in solar telescope manufacturers at the moment, because their market probably isn't particularly active at the moment. Despite the fact there's hardly any activity on the sun, though, we are still seeing aurora. This was a fairly low-level aurora taken by Denis Brzezinski, and Denis lives in a fantastic location on the Tarbert Peninsula in the north of Scotland. However, he's now living next to a building site. The field next door to him was sold and they're building a house in it, but he's assured that it's not going to have any bright lights on it. I certainly hope that's the case. I got sent this by Gillian Perry, really nice aurora that she saw from Fox in Alaska a couple of weeks ago. The Perrys kind of go to Alaska, I think, every winter to get their fix of aurorae. And I know certain people now, kind of, the winter is not the winter without travelling up to Norway or Iceland or the north of Sweden or something to see aurora. So it's good that despite the fact that the sun's pretty much switched off, aurorae is still happening, but they're all at a fairly low level at the moment. So here we go back to that picture. This is the full moon. It's quite an old picture, but Honor Wheeler posted this on the BAA website recently, and it's a really nice picture over what I guess probably is something in Dartford or Crayford or somewhere around there. But it shows the full moon low above the horizon. And it's a really interesting challenge, I think, and quite difficult to do, to actually position yourself in the right place to get the rising full moon with a long enough focal length lens that you can get a really nice picture like that. What with all of the problems with weather and other things, I think this is an absolutely fantastic picture, and something I'd encourage other people to have a go at doing. You know, get some pictures of the moon above well-known horizon foregrounds. Of course, these days the media can never have a full moon without calling it something. I think I saw something on the BBC website that the latest full moon was called the Worm Supermoon or something. Anyway, there you go. So I'm not sure what this one was. Maybe it was the crab supermoon or something. But basically, all you need to do is take a picture of the full moon, any full moon you want. When the BBC say, have you got any pictures of the worm moon, just send it in. They won't know any different. Now this is really nice. This is a demonstration of what you can do with good imaging systems on a really big telescope. This is a C14 image by Richard Bosnan. This is of Copernicus. Just look at the resolution of this. It is pretty amazing. You know, if somebody had told me this was from a spacecraft 100 miles above the moon, I'd believe them. I mean, just absolutely phenomenal that you can get this kind of resolution with modern cameras. You know, Richard said about stacking 1 million frames of Mars. You're not far off that with the moon because it's so bright that these days you can take videos at 150 odd frames a second or even faster. So you can stack a lot of them. But this is a really good example of what amateurs can do with big scopes. Really nice. Okay, just a quick tour around the sky. Starting in the evening sky, then we've got basically Andromeda disappearing. The only real planet that we have in the evening sky is Mars, and it seems to have been there forever. I don't know what it is about Mars, just its orbit, but basically it's just getting smaller and smaller and smaller, but it's been in the evening sky for a long time. In February we also had Mercury, and quite a lot of people actually got to see Mercury for the first time. Who here actually saw Mercury in the evening sky in February? Not that many people actually, but it was a really good elongation, so it was a good opportunity to see Mercury. At this time of the year the ecliptic is quite steep, and so Mercury, which is always very close to the Sun, was actually reasonably high up. So this is a nice picture by Steve Knight, which he entitled Mercury in the Murk, but there it is at the top. And then Andrew Patterson sent this one as well. There it is over there. At higher resolution at the time, this is an image by Stephen Kidden. No, I haven't put it in upside down on purpose. I'm trying to do something which planetary observers really annoy me about, is that they just randomly send images which are either south up or north up. So it makes it really difficult to compare things. So this was originally south up, so it's now north up, I think, as far as I can tell. At least it's the same way up as this next lot, which I think are north up as well. So it's really good what planetary observers can do nowadays. They can use WinDupos to take spacecraft imagery and actually simulate the lighting conditions and the resolution that they would get theoretically with their telescope, and then compare it with the real image. So this is the real image here. This is what a spacecraft would see, and this is what you see when you actually blur the spacecraft image. And you can see there's some really good correlation there between the markings that people are getting on the very, very small disk of Mercury and what we know to be actually there. So Mercury, of course, moves around so fast. It was briefly in the evening sky. It's now currently in the morning sky, so we'll get to it a little bit more at the end. Mars, these aren't the wonderful perihelic views of Mars, but still pretty impressive. This is Simon Kidd. This is a disk 5 arc seconds in diameter. So just to give you an example of the kind of resolution, so you know those pictures that Slipher took with photography and Drzesko took, which were absolutely fantastic with photography, this is what you can do now on a disk that's 5 arc seconds in diameter, just to show how things have advanced. So Mars will be there for a little while longer, but gradually the Sun is catching up with it, and it will eventually go into superior conjunction later in the year. As we move around, of course, we've still got Orion in the sky. A little bit later in the evenings at the moment, we've got some nice ISS passes. So there are really bright ISS passes almost overhead for the next few nights in the evening sky. So there's one tonight about 8 p.m. if you happen to be outside. This is last night's one that I caught on my all-sky weather camera that I run at home. So that's Castor and Pollux, those two stars there, and that bright thing passing Castor and Pollux is the ISS from last night. It's about magnitude -3.5, -4, so about as bright as Venus. So you won't miss it. So if you do have clear skies next few nights, go out and have a look. The passes are around about 8 p.m, but have a look on Heavens Above to find the actual time of the pass. Okay, a little bit further round in the sky, we've got two constellations with some interesting objects in, which I'll mention. So Cancer and Leo. And this is where it's going to get a bit audience participatory in a minute, so just be prepared. And I'm also going to mention the B word, which I've been trying to avoid mentioning all day, because I'm going to talk about this object. This is a blazar. It's OJ287. So this object looks rather boring. It looks like just a star in a rather boring field. It's about 15th magnitude. What makes it interesting is that it is a long, long way away. It's about 3.5 billion light years away. It's a binary black hole. It's a binary black hole that consists of a small, puny little 150 million solar mass black hole orbiting around a somewhat larger 18 billion solar mass black hole. So just think about that for a second. 18 billion solar masses in a black hole. The primary black hole has an accretion disk, and the smaller black hole, the 150 million solar mass black hole, orbits around the big black hole every 12 years or so. And as it goes through the accretion disk, you get a flaring of this object. So you can observe from your back garden, if you've got a reasonable sized telescope, you can look at this visually. You can observe a huge black hole orbited by a slightly smaller black hole, 3.5 billion light years away. Doesn't that make astronomy a pretty extraordinary subject, that you can do that? Anyway, various people are interested in measuring the light curve of this object, because you can either spend billions of dollars building a gravitational wave detector on the ground, or you can use a bit of maths on the way that this orbit is changing due to radiation of gravitational energy from these two objects. So the orbit precesses quite rapidly due to general relativity, because you've got two very massive objects. But it also changes slightly in period because of gravitational wave radiation from these objects. And by timing these flare events, we can get some very accurate constraints on this system. The next flare event happens when the secondary goes through the accretion disk next July, which just happens to correspond to this object being in solar conjunction, unfortunately. But the light starts rising from about now. So Gary Poynier, Mark Kidger are very interested in getting observations of this object. So if you're interested in observing this object, contact Gary. Gary can give you details of it, but it's about 15th magnitude, so it's relatively bright for modern telescopes and imaging systems. So here's a little bit of audience participation, right? This happens to be the core of the Andromeda Galaxy, M31. It's, each of these pictures is actually processed using what's called a median removal filter. So the average brightness is removed. So rather than seeing the galaxy, all you're seeing here is the core of the galaxy and all of the objects, all of the stellar objects within the galaxy. Can anyone spot a nova?
Yeah. 4 o'clock.
4 o'clock. That one? Yeah. That one? Or that one? Yeah, so there are actually 5 in this. I can't remember the other ones are, but if you're interested in trying to discover objects, M31 is a really good place to look with modern telescopes, because there are novae going off in it all the time. This one actually was discovered by myself and George Carey back in January. George surveys M31 a lot more than I do, but I just happened to be lucky to get it on that night. And Robin Ledbetter confirmed that it was a nova by taking a spectrum of it. So this is a completely amateur discovery and characterization of a nova in an external galaxy, which I think is a pretty neat thing. And the amateur spectroscopists now working on this are doing really good jobs of characterizing these discoveries, both novae when they can and supernovae. And this was actually about Mag 17, I think, so that's really impressive that amateur spectroscopists can do that. Anyway, I said I was going to mention some other objects which are around in this area. So in Leo is a galaxy which Ron Arbour has just made a discovery in. So NGC 3362 is a galaxy about 400 million light years away. Not a very exciting galaxy, but Ron, who is probably our one remaining supernova patroller in the UK, discovered a transient object in this galaxy, this object here. Now, there's a way of reporting these, and it's a bit complicated, but there's this thing called the transient name server, and that's the way that you report these objects. When Ron went to report this object, he found out that it was in exactly the same position as a previous supernova, a supernova called 2010 CT. And so what Ron did was, he actually reported it not as a supernova, but as potentially a supernova imposter, or effectively a variable star that wasn't a supernova, because essentially this thing was a supernova that had happened before, and it had reappeared. Unfortunately, spectral classification later showed that actually it wasn't the same object. It was a supernova in its own right, and an Italian team who didn't have the kind of, well, they just reported it as a new discovery, a new supernova. So even though Ron discovered this first and reported it first, Ron reported it saying it was in the same place as a previous supernova, and so probably an imposter. The Italian team reported it as a supernova, and they got credit for the discovery. That really is bad luck. And I'm seeing Ron on Friday, so I think I might need to commiserate with him a bit. But really bad luck for Ron there. But again, showing that he can discover, this is about an 18th magnitude object. Supernova imposters are actually quite frequent now. This is an image I took of M51, the famous Whirlpool galaxy, a few nights ago. It again has got an object in it which could be a supernova if you just go from the fact that it's a stellar object. In fact, spectroscopy shows that it's not a supernova. It's a large amplitude variable star, but not a supernova. So that's one of the things now. A lot of these things being reported as potential supernovae, they are only really supernova once people do spectroscopy of them. And a lot of the fainter objects that are being reported are currently not actually ever confirmed at all. So this is one of those areas for amateurs, really. If amateurs can actually get to the point that they can do spectral confirmation of objects at around the sort of 17th, 18th magnitude area, and Robin does that, then this is a really good area for people to work in. Moving around a bit into the morning sky, at the moment we've got, if you get up early, Jupiter and Saturn in Sagittarius, really low down. All of the images that we're sent now of these planets are coming from the southern hemisphere. Either, as in this case, they're from Clyde Foster in South Africa, who's actually been here and visited us in the past, or they're coming from remote telescopes. So Damien Peach's images, for instance, all now come from Chile. Or we get our images from Juno, and this is a pretty spectacular image, I think. So to have a spacecraft in orbit around Jupiter so you actually see it from angles that we never see from the Earth, I think is pretty amazing. And of course, here's the great red spot, a really nice red, almost as red as Richard's background on his Mars images. And this is what it looks like to Damien Peach. This is a fairly recent image that Damien's taken with a remote telescope in Chile. So remote telescopes aren't now just used for long exposure images, so supernova monitoring or variable monitoring. They're actually used by planetary imagers to take high-speed videos remotely and then process the data to get images like this. Saturn II is very low in the south, and here it is, an image by Trevor Barry. Again, this is from the southern hemisphere. So unfortunately for those of us in the north, those giant planets are now really far south. So getting images of them of any real quality is extremely difficult from these latitudes. Finally, as we move around in the sky, right at sunrise, we've got Venus here, moving towards its superior conjunction. And actually Mercury, little Mercury that was visible to us in February, is now coming out into the morning sky as it races around its orbit. So here's some images of Venus taken in ultraviolet, showing some of the cloud features. Again, a really good demonstration of what amateurs can do with imaging planets. And here's Mercury by Simon Kidd, showing the very thin crescent phase as Mercury comes out at inferior conjunction and heads to its greatest elongation west, which will be on April the 11th. So if you're up early in the morning, see if you can see Venus and Mercury in addition to Jupiter and Saturn. So just a final few things. Meteor showers. This isn't a very good time of the year for meteor showers. It's rather boring. Those of us who operate meteor cameras know that this kind of spring period is quite quiet. There's a continual stream of meteors from what's called the Anthelian source, which is a source opposite the sun in the sky that moves gradually along the ecliptic from now through to May. The main shower is the Lyrids on April the 22nd, peaking on April the 22nd, but this year, unfortunately, that will be very shortly after full moon. So not such a good time for the Lyrids. This video on the left here was a sporadic meteor that proves the rule about anything to do with imaging meteors is that the good ones always go off the frame whenever you get them. But this was a really nice bright fireball back on the morning, I think, of March the 9th. Not though as bright as this one. So you'll see the title here, it says fireballs reported by US government sensors. What could they possibly be, eh? So there are satellites up there looking for bright flashes, and they of course pick up fireballs. And they picked up on the 18th of December, the third largest known fireball detonation in our atmosphere, 172 kilotons. So quite a large detonation. It's interesting, and it is purely coincidental, I'm sure, but I'm sure if you're a conspiracy theorist, you'd go to it. The three largest known are Chelyabinsk, which is the big red one, the one over Kamchatka in December, and of course Tunguska. And they're all over Russia, or the Soviet Union as was, so something's going on there, suspicious. Anyway, this was a big one, about 1,600 tons mass, about 10 to 15 meters in diameter. This is a really nice time lapse from a weather satellite showing the dust train gradually dissipating in the atmosphere, and this one from the NASA Terra satellite showing it in the high atmosphere. So a really large object that nobody knew anything about at all until the US DoD declassified the detection from their satellites and then was reported. Obviously nobody in Kamchatka to actually see it, and even if they were, it's almost permanently cloudy there at that time of the year. A few things that are a bit further away that have happened recently. So asteroid occultations now is a really big area that amateurs do some very good work in. This is one that took place in March, and Alex Pratt sent this really nice plot of it. And it's an area where amateurs really excel, because essentially it allows, amateurs are spread all around the world, they can be in the right place to record these occultations. If you have enough people across the track, you can get the profile of the object And so you can get a lot of information about the object's shape, its very precise orbit details and all kinds of other things. And of course, if the object happens to have a companion, if it's a binary asteroid or something like that, there's always the possibility that you discover that companion in the data. So this is one of those areas, again, where amateurs are doing really, really good work, contributing a lot of scientific results to professionals, and where amateurs will continue to do that because amateurs are able to spread their telescopes around the world. Okay, comets. I haven't mentioned comets yet so far, so I just wanted to just go through where we are with comets at the moment. So I understand I didn't make it on Council, but my section was reviewed today, and the major complaint was that there were no decent bright comets for people to observe. And unfortunately, I can't promise any bright ones coming up, but we've had some fairly decent ones. In particular, this one, Comet 2018 Y1, Iwamoto, was discovered by a Japanese amateur, Iwamoto, and it basically came out of the blue. It was one of those comets that kind of sneaks in from the direction of the sun, hadn't been picked up by the surveys. It was discovered in December and actually reached its brightest in February. And it actually got to about 6th magnitude. It was a very diffuse comet, so one of those things that's very difficult to see if you have any light pollution. But it was ideal for images because it went all the way through Virgo and Leo and passed lots and lots of really nice galaxies. So here it is, passing M95 and M96. And here it is, passing NGC 2903. So a nice contrast between the galaxy down here and the green emissions from the comet. And if you remember, in February we had an absolutely extraordinary period of about a week of clear, lovely spring weather. So I managed to get images of this comet on 5 consecutive nights, and what I've done here is put them together into a panorama showing the comet basically as it's moving, as it's moving across the, get seasick. As it's moving across the sky, essentially here it's moving away from us, it's slowing down, it's fading, and you can see in these images it getting smaller and smaller and actually decelerating. Some really nice deep sky objects. It was moving through Auriga and Nick. Which open cluster was that? Which is the big open cluster in Auriga? 13 something.
37. That's 37, I think.
Right.
M37.
Yeah, so it was a really nice comet. We received lots and lots of images of it, and it came out of the blue. So even though we haven't got anything like that predicted at the moment, we know that such comets can just appear from behind the sun and potentially be really interesting objects to observe only a few months later. Comets, of course, range from comets like this, quite nice bright comets that were actually naked eye from dark sites, to comets like this, but this one is a comet that was discovered by the Atlas system, and it's in there somewhere, but it's actually easier to see at the top. Atlas is another of these acronyms. It's something like this Automated Last Alert Telescope System, and the idea of it is it's a small system for looking for small objects that are very potentially on their last sort of few million kilometers before they impact the Earth. And so there are lots of Atlas comets, but there are actually comets named after people on the Atlas program who also find them. So our friend Alan Fitzsimmons has now got a comet named after him that was discovered with Atlas, and this one was discovered by Flewelling. So these comets actually have nice names. They're not just Comet Atlas. So I think it was David took this. I can't remember. It is David Swan. Yeah, thank you. So yeah, this is David Swan's image that he took, and again, this is posted up on the BAA members site. So that's basically what's happening. The planets that are mostly in the morning sky. You've got the April Lyrids coming up. Various challenges with the full moon. OJ287 would be a really interesting object to follow through to its conjunction. And just keep an eye on the BAA website for any transient objects that come along, because there's a lot of stuff going on. I'd just like to plug 2 meetings that are coming up. Jeremy's already done the comment section meeting, which is in York. But also our September meeting this year is going to be a really, really good meeting. It's an absolutely stellar set of speakers, literally. It's got a kind of comet and small bodies theme to it. And it's in Armagh, and Armagh has got loads of stuff of interesting astronomical interest. I recently booked EasyJet flights over to Belfast, and I think they're about 50 quid return. So if you do it soon enough, it's not that expensive to get there. And the BAA has arranged a special room rate for the Armagh City Hotel, which is where the meeting's going to be. So if you want to go to that meeting, just have a look on the website at the moment. There's information about it. Get yourself flights booked early and get yourself booked into the hotel. The comment section meeting, again, a really good lineup of speakers, and that's in May, in York in May. York being York, accommodation is quite expensive in York, but there's plenty of places to get accommodation outside. And again, if you book a train out of King's Cross, and you choose the right times, you can get some really good deals. So I'd really like to see as many people as possible at those meetings, particularly the Armagh one, which I think is going to be a fantastic meeting. So thank you very much.